All right, here is the answer to this one. It should be 24. So these integrals look tedious, but actually some nice things happen. Some terms canceled out and combined before we integrated, like these x squareds right here, negative x squared and negative of negative x squared, which is positive x squared, they cancel out. You could combine these two. So this whole thing turns into this integral right here, from negative 2 to 0 of 3x cubed minus 12x. And then if you think about it, if you're just swapping, essentially the top and the bottom are swapping. So in the other integral, it just reverses the parentheses basically. So this parenthesis goes there and this parenthesis goes there. So what's really going to happen is our first integral is just going to reverse. So 3x cubed minus 12x in this blue box up here for our first integral, really just the terms just reverse position. And we get this down here. 12x, you're just negating the terms. The 3x cubed becomes negative and the negative 12x becomes positive. So it's 12x minus 3x cubed. When you integrate both of them, you get 12 for both of them. So your total area when you add them together is 24. Okay? Last one. Now sometimes you will see examples that have the orientation reversed. So no longer are we dealing with top and bottom here, because look at how the functions are expressed. They're expressed as x in terms of y. Usually 99% of the time in math, we're dealing with functions that are y expressed in terms of x. Y equals x stuff. Here, these examples are x equals y stuff. So that's essentially going to transpose our orientation. So instead of top and bottom, now we're looking at right versus left. So the right function really serves as the top now. And the left function serves as the bottom now. Okay? Because everything's getting transposed. So when we set up our integral, usually our inside our integral is top minus bottom. Here it's going to be right minus left. So it's going to be 3 minus y squared, which is our right function, minus our left function, which is y plus 1. And everything's in terms of y here, so we're going to put a little dy as our notation at the end. And then, how do we figure out what our numbers, our boundary numbers for our integral must be? Well, normally we look, when we're differentiating in terms of x, we look at our x interval from a to b, our x interval from left to right. But here we're integrating in terms of y. So instead of left to right, we're going to look at our units from bottom to top. So these 2 points where these curves cross, the units that go as our boundaries are going to be -2 to +1, the low to high. Normally you're looking across when you do integrals. You're looking at the leftmost x value to the rightmost x value. But here, since everything is shifted, or our orientation is shifted, we're going to look at the bottommost y value to the topmost y value, because we're differentiating in terms of y. So these numbers that are the boundaries of our integral have to be y units. Okay? And that's what all this says here, spelled out. I don't know what just happened there, but so now we got to do our integral. We could combine some like terms first. 3 minus 1 is just 2 minus y squared minus y from -2 to 1. So that's going to be 2y minus y cubed over 3 minus y squared over 2 when you do the integral from -2 to 1. Ran out of room here, but it's going to be 2 times 1 minus 1/3 minus 1/2, when you plug in the top number, the 1, minus 2 times -2 minus -2 cubed over 3 minus -2 squared over 2. So 2 minus a third minus a half here is 7/6 minus -4 minus -8/3 minus 2, which is -10/3. So 7/6 minus -10/3 is going to be, oh, this comes out to the same exact answer as we had above, 4.5. In example 2, right? Yeah. Now, look at that. 9/2, 4.5. And we get the same exact thing here. 9/2, 4.5. Now, why did that happen? Is that just coincidence? It looks like the curves in example 2 are the same exact curves as the curves in example 4. They're just expressed in reverse. That's why we get the same exact answer. The areas between the curves do not change at all. It's just the expressions of the curves that change. So in the top one, example 2, the curves were expressed as y in terms of x. In example 4, the curves are expressed in x in terms of y. But the actual space, the physical area between the curves is unchanged. They're just expressed in different variables. That's all. So we get the same exact answer because the curves are really the same. So that was a good check. Example 2 and example 4 come out to be the same exact answer because they're really the same curves. All right, so that's the lesson. You will have one last graded assignment. It's 4 problems. It's the 7.1 graded practice file in Drive. 4 problems. That's your last assignment for Calc. All right, everyone. Good luck.